Let's see this question. This question is given in GATE 2010 in the subject EDC. The gate oxide in the CMOS process is preferably grown using. The options are wet oxidation, dry oxidation, epitaxial deposition, and option D, ion implementation. We know that the oxidation process is nothing but the process of formation of SiO2 layer from silicon. Okay, and here we are dealing with the thermal oxidation. Thermal oxidation, and it is a process carried out in very high temperatures. Very high temperature that may ranges from 900 degrees centigrade to 1200 degrees centigrade. This is categorized into two types. One is dry oxidation, another one is wet oxidation. Dry oxidation, another one is wet oxidation. We will see these two categories one by one. Dry oxidation, wet oxidation. Now, dry oxidation is whenever oxygen reacted with silicon to form silicon dioxide layer. Our main aim of this thermal oxidation process is to form SiO2 layer. To form SiO2 layer from silicon. In the dry oxidation, oxygen is reacted with silicon to form SiO2 layer. Si reacted with O2 to form SiO2 layer. One of the main important advantage of this is it is having very good electrical characteristics. Good electrical characteristics. Okay, and it is acting as good dielectric. It acts as good dielectric material. Good dielectric material. Now it is having disadvantage. Disadvantages also. The main disadvantage is the growth rate is very low. The growth rate is very low for dry oxidation. The growth rate is very low. Coming to wet oxidation, it is also process of formation of SiO2 layer where we use highly purified deionized water or water vapor we use to form SiO2 layer. So silicon plus highly deionized water 2H2O gives rise to SiO2 plus 2H2. Here this is solid. Okay, this is gas. We are forming solid here. Okay, SiO2 layer is formed. The main advantage here is it is having higher growth rate. Higher growth rate, and it is having poor electrical characteristics. That is the disadvantage here. It is having poor electrical characteristics. Electrical characteristics. Now coming to this dry oxidation, it is having the width is very small here, so it acts as dielectric, and it is also called thin oxide or gate oxide. Thin oxide or gate oxide, because width is very small. Width here is very small. So for this question the answer is dry oxidation itself. Okay, the gate oxide in a CMOS process preferably grown in dry oxidation. Why not wet oxidation? The wet oxidation act as perfect isolation. Okay, perfect isolation, because it is also called thick oxide. Thick oxide. Whenever we are dealing with very high circuits, big circuits, there we need to use lots of transistors. Here transistors are need to be placed side by side, so we should not interfere one transistor among other. So in such case the isolation should be needed. So this thick oxide act as perfect isolation such that we will get the required results. So for this question answer is dry oxidation.